In this video, we're going to be learning how we can use our calculator, the one I have over here, and how we can use it to make trigonometric graphs. Actually, not to make trigonometric graphs, but to sort of like find out values that can then help us make trigonometric graphs. And just so we're clear, you don't need like a really advanced calculator. Okay, you can. I'll show you that how we can do it in both of these calculators that I have over here. Okay, this calculator is slightly damaged from here. Okay, but I hope it's clear in the video. Yeah, anyway, so let's get straight to it. So this is a question over here. This is from May June 2021, paper 2, variant 2. So obviously there are going to be some parts before we actually get to the sketching part. So over here it says write down the amplitude of f. So amplitude is the value in sine and cos, is the value that you have just with the function, just with the trigonometric function, okay, in case of sine and cos. Okay, so over here the amplitude is going to be 1. Okay, that's a no-brainer. Now in order to work out the period, well, the formula for working out the period is basically we take the natural period, which in the case of sine and cos is 360, and we divide it by the coefficient of x, which is 2/3 in this case. So coefficient of angle basically, which could be x, could be theta, depends on the question really. So I can do that in any one of these calculators over here. So I'll make a fraction key, do 360, take it in the denominator, and then work out 2/3. Okay, so that gives me what? That gives me 540. So that means one cycle of this trigonometric curve right over here is going to end in 540 degrees. Okay, so hopefully that's clear. Now the next thing over here, it says that sketch on the axis, sketch the graph of y is equals to f of x. Okay, let's do that. So you can see that we have values starting from 0 going all the way to 90. Again, you can see that we have y values from -5 to +5. Okay, now I'm going to show you how you can use any of these calculators over here. So if we start with the first one, okay, so just turn your calculator on, make sure it's in degree mode. Okay, then you navigate to where you see table. Okay, so that's at number 9. There you go. You write down the trigonometric function, which we can see is -2 plus cos 2x/3. So I'm just going to write that, -2 plus cos, make a fraction 2/3 and put x, which by the way is equal to alpha x. Okay, then g of x, in this calculator you have a benefit of finding out the values of two functions at once. Okay, that's not something we have in this one. The starting value is 0. As you can see over here, the starting value is indeed 0. Okay, the ending value is 810. Okay, now the step, well, this is the part where we'll have to be slightly flexible, in the sense that yes, there is a standard way of finding out the step, but sometimes you have to change your step depending on the graph that's given. So here I think the ideal step would be to have values that we can plug in after every 90-degree interval. Now just so you guys know, step is basically your calculator is trying to ask you after how many interval should it plug in the value. Okay, so if we say 90, so that means it's going to start from 0, then plug in 90, then 180, then 270. So it's going to plug in value in the function after every 90-degree interval. So we're going to write 90 and go ahead with it. So you can see here that we have our answer. At 0 it's -1, so that means it's right over here. At 90 it's 1.5, so 1 2 3 4. So at 90 it's 1.5, so it's going to be right over here. At 180 it's -2.5. Sorry, at 90 it was actually -1.5, so I'm just going to quickly fix that. -1.5 is going to be in between -1 and -2. At 180 it's -2.5, so that's going to be in between -2 and -3. And at 270 it's -3, so at 270 it's -3. There you go. And then let's scroll down. So at 360 it's -2.5 again, and at 450 it's -1.5 again. There you go. And at 540 it's -1. That means one cycle has completed. So there you go. Try and make it as smooth as possible and shouldn't be sharp. And the next cycle is going to continue in the same direction, you know, the same way as this one. Okay, but whoops, sorry about that. But if you want to see what the actual values are, well, you can just navigate downwards, and you can see at 630 it's -1.5 again. At 720 it's -2.5, and at 810 it's -3. So you can just continue like this over here. Now what if you wanted to use this calculator? Well, you can do the exact same thing in this one also. All you have to do is press mode, go to where you see table at. Okay, and over there you just enter the function as it is. Okay, so you have -2 plus cos. Again, make sure your calculator is in degree mode, which it is. make a fraction, write 2 upon 3, put x with 2. Okay, so I'm going to do just that. Alpha x, close the bracket, not like that, but after the end of the angle, like that. Okay, what's the starting value? 0. What's the ending value? 810, as we saw earlier. Okay, what's the step? 90. And there you go. Okay, you have the exact same values as you have over here. Okay, now we're going to do one more question, and this time we're going to keep it in radian. Okay, so you can understand that we can, you know, do the exact same thing in radians. And this is a question from October-November 2020, paper 1, variant 2. Okay, so it begins by asking you the same thing as it did earlier. Write down the amplitude, so you can see that the amplitude is 2. Write down the period. Well, in this case, since we're dealing with radian, so we're not going to take 360. Instead, we're going to take 2 pi and divide by the coefficient of angle, which is 1 upon 3. Okay, and why 2 pi? Because 2 pi is the natural period. Okay, just by the way, in order to go back to regular mode, just press more than 1 in both the calculators. So here's my fraction, 2 pi, sorry, shift and pi, divide by 1 upon 3, sorry, not 3, divide by 1 upon 3, so that gives me 6 pi. That means one cycle will complete after every 6 pi radian. Okay, now first thing that I'm going to do is I'm going to convert both these calculators in radian mode. So for that, for this one, you press shift and menu, you go to where you see angle unit at. Well, where is it? It's radian is at number 2, so you press that. In this one, you press shift and mode. You can see that over here it's directly asking you what you can directly see radian over here, so just press 4, so enter into that, and there you are. Okay, now over here it says on the axis below, sketch the graph of y is equals to 2 cos x upon 3 minus 1 for minus pi to 3 pi radians. Okay, so again, you can use any of these calculators. Now one thing with radian is a slight drawback is you can't actually see the x value in terms of pi. Okay, your calculator just converts it into decimal and then gives it to you like that. Okay, so that's a little drawback, but anyway, nothing to be worried of. So you go to where you see table at. Okay, let's just do it side by side. Okay, now you enter the trigonometric function, which is 2 cos, so here's cos, make a fraction, alpha x upon 3, close the bracket, write minus 1 after it. Okay, let's do the same over here also. 2 cos, bracket open, alpha x upon 3, bracket close, minus 1. Okay, where do you want to start? Okay, skip that. Start at minus pi. Okay, so minus, shift, pi, and you'll instantly notice that your calculator likes to, you know, convert that into decimal. But anyway, nothing to be worried of. Minus pi. Okay, where do you want to end it? You want to end it at 3 pi. So 3 pi. Okay, let's do the same over here. 3 pi. Okay, what step do you want to take? Well, according to a graph, you can see that we'll have to take step of pi. Okay, because we want to see what values are after every pi degrees. Okay, so we're gonna change the step to pi. Okay, and over here also we'll do the same, change the step to pi, press equals to, and there you can see you have all the values. Okay, so the first value is basically minus pi. Okay, and at minus pi it's 0, so you can see over here. The next value 0, so over there it's 1, and the next value, which is 3.1415, that's also pi, so that means it's 0 over there. And then at 2 pi, now you'll have to keep track of values yourself. Okay, so this value has to be 2 pi, so at 2 pi it's minus 2, so that means somewhere over here. Okay, where I'm marking. Okay, or somewhere over here. And at 3 pi, which is going to be the next value, is at minus 3, so that means somewhere over here. So it's best to use a scale. Okay, I'm not using a scale, so my graph may not be as accurate as I'd like, but yeah, it does the job. And you can see that you've gotten the exact same values over here also. Okay, now all you got to do is just join them with the help of a smooth curve. So I'm just going to join, whoops, sorry, shouldn't be too jerky. Okay, let's try and keep it as smooth as possible. So there you go, and then let's join the other end over here, and that's it, you're done. So I hope you guys have understood how you can use your calculator. It doesn't matter which version it is. You can use, as you can see, I've used a very advanced one. This is advanced as it gets, and also a not so advanced one. So you know, you have this feature in both these calculators. So yeah, I hope this is clear to all of you now. Once you're done with radian mode, make sure to convert it back to normal, or else you'll end up getting all the wrong answers. So yeah, hopefully that's clear, and that's it for this video. If you've liked it, make sure to hit the like button and subscribe to the channel if you haven't, and share it with your friends and classmates or whoever you think can possibly benefit from it. So yeah, that's all for this video. See you guys in the next one. Until then, take care. Bye bye.